For 6 weeks, we've mapped the infrastructure race to power AI, grid consolidation, nuclear financing, critical minerals, and agent safety. This week, we ask, does edge inference change that thesis? The answer, no. It multiplies it. Edge inference is shipping now. NVIDIA launched RTX Spark for laptops. Qualcomm showcased Dragonwing at Computex. Apple announced Metal RT at WWDC. MediaTek is pivoting toward AI racks. Qualcomm is acquiring Tenstorrent for $8 to $10 billion. Every major chipmaker is racing to own the edge AI layer. The neural processors market is projected to exceed $1 billion by 2035. But as AI chips get smaller, infrastructure is becoming more distributed. Micro-edge data centers, 250 kilowatts to 1 megawatt each, are being co-located at telecom sites and grid substations. 1,000 micro-edge sites create a 250 megawatt virtual data center with ultra-low latency. These can be deployed in weeks, bypassing the decade-long power backlogs of hyperscale facilities. But edge inference has a hidden cost: battery life. Running a modern vision transformer on a smartphone drains the battery in under 2 hours. Model quantization reduces energy by 75% but cuts accuracy. Transmitting data over 4G uses 5 to 10 joules per megabyte. Running inference locally uses 0.1 joules. For continuous workloads, cloud offloading drains batteries 10 to 100 times faster. This forces a brutal trade-off: model compression, hardware-software co-design, and constant cloud retraining. Edge inference intensifies cloud through 2 mechanisms. First, model drift. Edge devices degrade faster than cloud models. Constant retraining and updates push back to edge. Every device becomes a feedback loop, intensifying cloud training demand. Second, the query layer. Traditional edge AI is reactive, detect and alert. Modern edge AI is searchable, capture structured representations of the physical world. An excavator at a construction site doesn't send raw video, it sends structured site data. A safety officer queries, "Show me all worker proximity violations from the last week." This happens at the edge, without video transmission. Edge devices become intelligent nodes. The cloud becomes the query orchestrator asking, "Find me X condition across your distributed network." Fewer raw bytes, more intelligent queries, more cloud decision-making. Chipmakers capture new total addressable market. RTX Spark, Dragonwing, Metal RT are entirely new revenue. Model optimization infrastructure solves the energy constraint. Companies building hardware-aware neural architecture search, quantization tools, and edge ML ops create billion-dollar markets. Cloud companies intensify training. Hybrid architecture increases their total infrastructure spending. Grid operators face higher baseline demand. Micro-edge density adds 250 megawatts of distributed load, making nuclear, grid consolidation, and critical minerals more urgent. Our model of infrastructure is necessarily imperfect. Edge inference complicates what we thought was simple. But the thesis holds. Edge doesn't reduce infrastructure. It multiplies it into greater complexity. The nuclear bet, grid consolidation, and critical minerals thesis accelerates. More details and sources in the newsletter. Thank you for watching. Until next week.